Okay, let's move on to lab 11. So lab 11 will be similar to what we have in lab 8, I guess, right? So you basically have the current equations, you have the math equations to verify how the MOSFET will be in active region, and you have the small signal models here. And you can use the same techniques of finding the input and output resistances that we did for the BJTs. It's the same techniques, it's just that you have a different value, looking into the gate, looking into the source, and looking into the drain. And working with MOSFETs is way easier than working with the BJTs, right? Because looking into the gate over here, there is nothing connected, so the input impedance will be infinite, right? So that's why you have the Z gate infinite. Z drain is also infinite for the same reasons it is in the BJTs, and the Z source will basically be 1 over GM. Similarly, you can also use these gain equations. Remember, I tried to separate the whole circuit into stages, and you can use the gain equations also, right? But coming to the main portion, if you stick to the formulas, the pre-lab is pretty straightforward, and it runs similar to what you had in the BJTs. You first choose your VRS voltage, and I recommend that you choose VRS equals to 1. And you choose the swing, so choose V naught hat equals to 1 volts. So once you chose these two, you can basically go ahead and use this formula to find your VRD. All of these formulas here are just an explanation of how you got to. It is just an explanation of how you got to this formula. But let's see, you know your VDD, which is 5 volts. V naught hat is chosen here. VRS is chosen here. The gain is given, 25 is given in the lab manual. So you know all of these values, you can basically find VRD. So by the end of this step, you'll basically have your VRS, you'll have V naught hat, and you'll have VRD. Any questions in just these two sentences? All right. So once you have these values, now we move on to the next step. Here you'll calculate the overdrive voltage using your VRD. Once you find your overdrive voltage, you'll basically find your ID. Keep in mind that ID here is half beta V overdrive square, correct? And the overdrive value is something that you just calculated over here. But where do you get this beta from? This beta comes from lab 10, right? In lab 10, we basically calculated beta for those, right? You calculate your beta here, and this is your VT. That's what you calculate in lab 10, right? So that's where you get your beta from. It comes from lab 10, right? That's the value we borrow from there. Yeah, once you find your ID, you have everything you need, and you just have to calculate your resistance values. So you find your RD, RS, RG1, which is similar to RB1 in BJTs. This is your RB2, right? Here there is some additional term, which is RID. What it says is that RID is the desired input resistance. Let's see what is our desired input resistance. It says your input resistance should be at least 10 kilo ohm. So you can choose like 10 or 15 kilo ohm as your RID, and you should be good to go, right? So RID is something you choose based on the requirements. So you can choose RID, any value which is greater than or equal to 10 kilo ohm. And what else do we not know over here? I think RG1 is via calculator. I think VT is not known, but again, VT also comes from lab 10, right? Yeah, these are the two values that come from lab 10. That's it. Now we have all the resistance values you need for the pre-lab of lab 11. Any questions on the hints for pre-lab? Yeah, these calculations are easier than what you see in the BJTs. But if you follow step by step, like I said, you can ignore most of the part here because that's just an explanation, and just skip to the final formula over here. So let's see what calculation says. Use the 2N7000G model. Don't forget to make this non-ideal, right? design the common source amplifier using these specifications. And once you design that, you can use the same resistance values for the other circuit, but you'd have to calculate your AV, RI, and R out. So in the second circuit, all you have to do is just use these three formula and find your AV, RI, and R out. So yeah, calculations for this circuit is not too difficult. Only time consuming portion is your measurements, which again, everything you already did in lab 9, that's happening this week.